In interpreting observational records of climate, we need to consider both natural and human factors that might cause it to change. The greenhouse effect is a name often given to the process whereby the atmosphere allows solar radiation to pass through and heat the Earth, but trap the Earth's heat radiation. The Earth is constantly bathed in the sun's radiation, which supplies all the energy that drives weather and climate, averaged over the globe and over a year. The incoming solar energy is balanced by heat energy emitted by the Earth out to space, so that the Earth is maintained in equilibrium, absent other factors. Only about half of the incident energy reaches the surface, as about 29% of the incoming solar radiation is reflected back to the space by bright features such as cloud or icy surfaces, and about 23% is absorbed by the atmosphere. The solar energy causes the surface to warm and emit infrared heat radiation. About 90% of the heat energy from the surface is absorbed by the atmosphere, which then warms and itself emits heat both upward to the space and downward, inducing further warming of the surface. Natural factors that influence climate change. Changes in the amount of solar radiation reaching the Earth will impact surface temperature and climate. There are two fundamentally different ways in which this can arise. Through variation in Earth's orbit, changes in the amount of energy actually emitted by the sun. The sun's energy output provides a radiative forcing which impacts global surface temperature, warmer and cooler, by a few tenths of 1 degree Celsius. The sun is an active star, powered by nuclear fusion reaction at its core and intermittently emitting huge bursts of plasma to space. One obvious manifestation of its variability are the sunspots, which grow and fade across its surface approximately every 11 years. The idea that the sun may influence the weather has featured through the human history, but the ways in which it might achieve such an influence has never been clear.
As mentioned above, the light reflected back into space factors into the temperature of the planet. Solar radiation accounts for infrared, visible, and ultraviolet light. When the sunlight hits the Earth, it reflects diffusively. This varies from regular or specular reflection because diffusive reflections spread the rays out in many different directions. This can happen for two reasons. Either because there are different crystals or bits that make up the surface, such as ice, and between the ice crystals, there are boundaries that change the angle of the rays. This creates secondary and tertiary rays that end up spreading out in different directions. The second reason is because of the rust surfaces that when hit, they microscopically reflect into many different angles. This is the equation for an approximation of the albedo, with alpha being the actual albedo. 1 minus d, alpha with the angle, is the component of the regular reflection, the angle being between the point perpendicular to the Earth and the center of the sun, and the other part being the diffuse reflection component. The sum of these two will give you the actual albedo of an area.
So how does the albedo effect connect to humans and the environment? So, usually buildings are finished with white exteriors to keep them cool, because white surfaces reflect the sun's energy. Black surfaces reflect much less. People wear light clothes in summer rather than dark ones for the same reason. A big part of the Earth is snow and ice. Snow and ice reflect a lot of the sun's energy back into space. The darker oceans, like this, absorb energy, which warms the water. Oceans help keep the Earth warm because they absorb a lot of heat, approximately 90%. This warming increases water vapor, which acts as a greenhouse gas and helps to control temperatures. Every year, albedo peaks twice. The first peak occurs when the Antarctic Sea is at its winter maximum. The second peak, which is larger, occurs when there is snow cover over much of the northern hemisphere. Albedo also changes due to human interaction. Forests have lower albedo than topsoil. Deforestation increases albedo. Burning wood and fossil fuels add black carbon to the atmosphere. Some black carbon settles on the surface of the ice, which reduces albedo. The most significant projected impact on albedo is through future global warming. With the exception of the Antarctic sea ice, recently increasing by 1% a year, nearly all the ice of the planet is melting. As the white surfaces decrease in area, less energy is reflected into space, and the Earth will warm up even more. The loss of Arctic ice is a particular concern. The ice is disappearing quite fast. Not only albedo is decreasing, but the loss triggers a positive feedback loop. By exposing the ocean surface to sunlight, the water warms up. This melts the ice from underneath, while man-made CO2 in the atmosphere warms the surface. Humidity also increases. Water vapor is a powerful greenhouse gas. More ice therefore melts, which exposes more water, which melts more ice from underneath. Loss of albedo in the Arctic will accelerate warming across adjacent permafrost, releasing methane. Melting permafrost may reduce its albedo, another positive feedback loop that will accelerate warming. Ocean warming from reduced Arctic albedo will also accelerate melting at the edges of the Greenland ice cap, speeding up sea level rise, which has a lot of negative effects on the environment. And finally, increased water vapor also has another effect, which is to increase the amount of clouds. As mentioned already, clouds can increase albedo.
Solutions to the rising temperature regarding albedo would be to take it into consideration when designing and constructing buildings, such as making them white, for example, and reducing the costs that would be spent on air conditioning, also reducing greenhouse emissions. The second solution would be to synthetically create clouds and spread them over an area to increase its albedo. Any artificial solution that would increase the albedo has the potential to motivate natural sources, such as forming ice caps, to generate and create a positive feedback loop as the Earth's temperature decreases by man-made sources.